Get ready to have your mind blown as we uncover 10 mind-boggling phenomena unfolding in the vast expanse of space that will leave you questioning everything you thought you knew about the universe. From mind-bending cosmic collisions to mind-expanding revelations about distant galaxies, these jaw-dropping discoveries will challenge your imagination and stretch the limits of what you believe to be possible. Ancient cultures like the Chinese and the Greeks looked up at the sky in awe and racked their brains to figure out just what was going on up there. They made remarkable breakthroughs, but things ramped up in the 20th and 21st centuries as technology advanced. Some of those discoveries might be unfathomable to the non-scientists out there, but they're certainly real. Here are 10 things going on in space you won't believe. 1. Curved space. The idea that space can be flat or curved is strange and maybe not even believable, but alas, it is true. Albert Einstein realized the space around gravitating objects is curved, which accounts for things like orbits. More on that next. One way to determine whether space is flat or curved is by testing Euclidean geometry in these spaces. This is geometry performed by Euclid, a mathematician from ancient Greece that wrote up all the formulas you learned in high school geometry. For example, in Euclidean geometry, a triangle's angles add up to 180 degrees. Not in curved space. It's because the curvature of the straight lines, what an oxymoron, causes the angles to be bigger. You could draw a triangle with 390-degree angles. 2. The knot force of gravity. Remember in high school physics when you learned Isaac Newton's 3 laws of motion and the force of gravity? Force is mass times acceleration, or 9.8 meters per second squared. Forget it. Almost. Newton was not completely wrong with his laws about gravity. However, he wasn't completely right. It turns out, in his formulas, you could theoretically get answers, like the potential for infinite gravity, that just don't add up, and Albert Einstein saw that. He then came up with his equations that answered questions about gravity that Newton's equations couldn't. This is how we get curved space, which causes the phenomenon of gravity. 3. Einstein's theory of relativity. Einstein's theory of relativity is a complicated one, so hang on to your hats, boys and girls. This one plays in with curved space and gravity not being a force, but it is by far its animal. On larger scales, as an object moves from an observer, time slows down to that observer. For instance, if you hold a clock in front of you, the seconds will tick like normal. Move that clock farther away, and those seconds and minutes, from your perspective, will slow down. They don't slow down, but they look like it. 4. Black holes. Black holes are still a great mystery. Their very nature is what makes them so difficult to understand. For one, you can't see them. Their gravity is so strong nothing can escape, including light. Matter would have to move faster than the speed of light to get out of the grip of gravity, called escape velocity, which is impossible. This is how black holes got their name. No light comes out of them, so we can't see it. Therefore, it's black. Simple, except they're not so simple. Black holes are a sort of stellar carcass. When a massive star, much bigger than our sun, dies, it blows up into a supernova and will collapse into a neutron star or a black hole, the latter of which is completely unlike a star. Black holes have an extreme gravity that leads to a singularity where there is infinite density, where all of the mass is packed, and where time stops completely. The event horizon is the point of no return on the outer part of the black hole where the escape velocity exceeds the speed of light and space and time move in one direction, forward. 5. Alternate universes. This one does sound like pure science fiction, but it is a legitimate concept that scientists have grappled with for a century. During World War I, Karl Schwarzschild wrote up the first equation about black holes, like their radii, and even more fascinating, what's inside. He wrote that in a single instant, the singularity, that point of death that crushes you, connects to an infinite parallel universe completely independent of but within our universe. Even crazier is what a man named Roy Kerr wrote. His equations apply to a rotating black hole. That makes a world, or worlds, of difference. His equations turn the singularity into a ring instead of a dot. 6. White holes. A white hole is the complete opposite of a black hole because nothing can go in. It is structured just like a Kerr black hole, though, in that its singularity is ring-shaped and acts as a gateway to other universes. It does have an event horizon as well that does not allow those who cross it to come back inside because space and time are that strong. There are no white holes in our universe. These are purely hypothetical and come with the math behind black holes. Even if hypothetical white holes existed in hypothetical universes in hyperspace, we would not be able to access them simply due to the nature of black holes. 7. Wormholes. These are also results of the equations behind black holes and white holes, but don't necessarily have to do with alternate universes and hyperspace. Instead, these deal with our universe. According to the equations, these wormholes could connect space-time as a shortcut. To visualize this shortcut concept, imagine a giant block of concrete in front of you. To get directly to the other side, you have to go around it. The straightest route you could take is to walk directly to it and rub your shoulder along the edge as you walk around it. To make it shorter, you could just cut a hole in the concrete and go through it. Same place, same universe, but a different and very difficult way. 8. Dark matter. Less brain-melting but still puzzling and crazy is that there is so much stuff in the universe, but the catch? We can't see it, we don't know what it even is, and it's everywhere. That's about all we know about dark matter, the substance that makes up 27% of the universe. And dark energy, something totally unrelated but just as mysterious as dark matter, make up another 68%. Normal matter, like the protons and neutrons you're made of, makes up only about 5%. Dark matter was discovered by Vera Rubin when she realized the total mass of galaxies was more than the mass that the detectable objects in the galaxy should have added up to. That means that there's something in these galaxies that can't be seen or detected that has mass. 9. Whatever it is, the universe is expanding into. Along cosmological lines is another big question. What is outside the universe? Many know that the universe goes on forever. It has no edge and no center, but it is constantly expanding. That is, the space between galaxies is growing. This can be seen in the redshift of nearby galaxies. Redshift happens when an object is moving away from us. Therefore, its wavelengths of light are getting bigger, so the light is getting redder. So, the universe is expanding. But what is it expanding into? What is on the other side of the universe? This concept is mind-boggling and certainly difficult to fathom, but this is real life. 10. Gravitational lensing. This last one is perhaps the least mind-blowing, but it still makes you scratch your head. It has soundly been proven, but that doesn't make it any less crazy. Gravitational lensing is when you observe an object to be in some position in space, but it isn't there. This is because the light being emitted from its actual location is being refracted due to the gravity of an object that is in the way. As we reluctantly bid farewell to this mind-boggling journey through the astonishing events unfolding in the depths of space, one thing remains abundantly clear. The universe is a playground of unimaginable wonders that defy the limits of our comprehension. From mind-bending phenomena like black holes merging in a cosmic dance to the mind-blowing discovery of potential extraterrestrial life on distant moons, the tapestry of space is woven with threads of breathtaking intrigue. If you found our video informative, kindly subscribe to our channel so you won't miss out on our videos.